For an outdoor electrical installation involving a transition from underground feeder cable, specifically type UFB12/2 with ground, to electrical metallic tubing, the selection of a suitable junction box is critical to ensure safety and reliability. The junction box serves as the transition point between the direct buried cable and the conduit run leading to weatherproof receptacles on an outdoor stage. The primary requirement for the junction box is that it be weatherproof. According to the National Electrical Code, equipment that is rainproof, raintight, or watertight meets the requirements of being weatherproof. Therefore, choosing a junction box rated for outdoor use is essential. Several options are available, categorized by their NEMA ratings, which indicate their level of protection against environmental factors. Firstly, NEMA Type 3R junction boxes provide protection against rain, sleet, snow, and the formation of ice. These are suitable for general outdoor use where exposure to the elements is expected. Secondly, NEMA Type 4 junction boxes offer a higher level of protection. They are designed to protect against splashing water, hose-directed water, and the ingress of solid objects. This makes them suitable for environments where the junction box may be subjected to more direct water exposure. Thirdly, NEMA Type 6 junction boxes provide the highest level of protection among these options. They are designed to protect against temporary submersion in water, in addition to the protection offered by NEMA Type 4 enclosures. This level of protection is typically required in situations where the junction box may be submerged for short periods. In addition to the NEMA rating, the construction of the junction box is important. It should have a gasket or other sealing mechanism to prevent water from entering. The gasket material should be durable and resistant to degradation from exposure to sunlight, temperature changes, and other environmental factors. Furthermore, the junction box should be made of a material that is corrosion resistant, such as stainless steel, aluminum, or a non-metallic material specifically designed for outdoor use. The connectors used to terminate the wires inside the junction box are also crucial for maintaining a weatherproof seal. Weatherproof connectors are designed to prevent water from entering the connection and causing corrosion or electrical faults. There are several types of weatherproof connectors available. One option is wire nuts with built-in gaskets. These wire nuts have a rubber or silicone gasket that seals the connection when the wire nut is tightened. This prevents water from wicking into the connection through the strands of the wires. Another option is heat shrink connectors with built-in seals. These connectors consist of a metal crimp connector surrounded by a heat shrink sleeve that contains a sealant. When the connector is crimped onto the wires and the heat shrink sleeve is heated, the sealant melts and flows around the wires, creating a waterproof seal. A third option is crimp connectors with rubber seals. These connectors use a crimp connection to mechanically secure the wires together and a rubber seal to prevent water from entering the connection. The rubber seal is typically molded around the connector body and compressed when the connector is installed. When installing the underground feeder cable, ensure that it is buried at the correct depth as specified by the National Electrical Code and local regulations. The depth of burial depends on the voltage of the cable and the type of soil. The cable should be installed in a trench that is free of sharp rocks and other objects that could damage the cable insulation. Backfill the trench with clean soil and compact it to prevent settling. When transitioning from the underground feeder cable to the electrical metallic tubing, use a suitable fitting to connect the cable to the conduit. This fitting should be weatherproof and compatible with both the cable and the conduit. Seal the fitting with silicone sealant or other weatherproof sealant to prevent water from entering the conduit system. The electrical metallic tubing should be installed according to the National Electrical Code and local regulations. Ensure that all connections are tight and that the conduit is properly supported. Use weatherproof fittings to connect the conduit to the junction box and to the weatherproof receptacles on the outdoor stage. The weatherproof receptacles should be installed in accordance with the National Electrical Code and local regulations. They should be mounted in weatherproof boxes and covered with weatherproof covers. The covers should be designed to protect the receptacles from rain, snow, and other environmental factors. Grounding is an essential aspect to electrical safety. Ensure that the grounding conductor in the underground feeder cable is properly connected to the grounding system in the subpole and to the grounding terminals in the junction box and weatherproof receptacles. This will help to protect against electric shock in the event of a fault. Inspect the electrical system regularly to ensure that it is in good condition. Check for any signs of damage, such as cracked or broken conduit, damaged wires, or loose connections. Repair any damage immediately to prevent electrical hazards. When working with electricity, always take precautions to protect yourself from electric shock. Wear appropriate personal protective equipment, such as rubber gloves and safety glasses. Turn off the power to the circuit before working on it. If you are not comfortable working with electricity, hire a qualified electrician to do the work. The NEC provides specific guidelines for working with underground feeder cables and outdoor electrical installations. Firstly, Article 300.5 covers the minimum cover requirements for direct buried cables. The depth depends on the voltage and whether it's under a building, driveway, or other location subject to vehicular traffic. For a 60 amp circuit, the typical burial depth is 24 inches, but this can vary, so consult the local electrical codes and Table 300.5 for accurate depth. Secondly, Article 314 details the requirements for junction boxes, conduit bodies, and handheld enclosures. It specifies the types of enclosures suitable for wet locations and the requirements for supporting and grounding these enclosures. Ensure the junction box is listed for wet locations, meaning it meets NEMA 3R, 4, or 6 standards as discussed. Thirdly, Article 358 covers the use of electrical metallic tubing, or EMT. It outlines the approved uses and installation requirements, including support intervals and proper fittings for connections. EMT must be properly supported every 10 feet and within 3 feet of every box or fitting. Use only fittings listed for use with EMT and ensure they are properly tightened. Fourthly, Article 406.9 addresses receptacles in damp or wet locations. It requires that all 14 and 20 amp, 125 and 250 volt receptacles installed in wet locations have an enclosure that is weatherproof whether or not the attachment plug is inserted. This is often achieved using an in-use cover. Fifthly, Article 250 covers grounding and bonding. This is crucial for safety. Ensure the grounding conductor is properly connected to the subpole's grounding bus and extended to the junction box and all downstream receptacles. Use appropriate grounding connectors and techniques to maintain a low impedance ground fault path. Choosing the right materials is also essential for the longevity and safety of the installation. Underground feeder cable type UFB is designed for direct burial and is sunlight resistant. Ensure the cable is properly sized for the 60 amp circuit, which is 12 American wire gauge for a 20 amp circuit. While 12/2 with ground is adequate for a 20 amp circuit, ensure overcurrent protection matches the wire size. For the EMT run, use galvanized steel or aluminum conduit for corrosion resistance. Use weatherproof fittings that are listed for use with EMT and are suitable for wet locations. For the weatherproof receptacles, choose those that are specifically designed for outdoor use and have a NEMA rating suitable for the environment, such as WR weather-resistant receptacles. Use in-use covers that completely enclose the receptacle when a plug is inserted. When making connections in the junction box, use the appropriate weatherproof connectors, such as those with built-in gaskets or heat shrink seals. Ensure all connections are tight and secure to prevent moisture ingress and electrical faults. When installing the underground feeder cable, avoid sharp bends or kinks that could damage the cable insulation. Use a shovel to create a smooth trench and backfill, with soil free of rocks or debris. When connecting the UFB cable to the EMT conduit, use a weatherproof fitting that is designed for this purpose. Seal the fitting with silicone sealant to prevent moisture from entering the conduit. When installing the EMT conduit, ensure it is properly supported to prevent sagging or damage. Use conduit straps or hangers to support the conduit at the required intervals. When terminating the wires at the weatherproof receptacles, use the appropriate terminals and tighten them securely. Ensure the receptacle is properly grounded and that the weatherproof cover is installed correctly. After completing the installation, test the circuit to ensure it is working properly. Use a multimeter to check the voltage and current at the receptacles. Also, test the ground fault circuit interrupter protection to ensure it is functioning correctly. Finally, document the installation, including the location of the underground feeder cable, the type of junction box and connectors used, and a wiring diagram. This will be helpful for future maintenance and troubleshooting. Remember to consult the latest edition of the National Electrical Code and local regulations for specific requirements and guidelines. Working with electricity can be dangerous, so take all necessary precautions to protect yourself from electric shock and other hazards.